challenge of being a scientist but working in the private sector. This really is not just me, and we don't learn anything about it. And what's more, it really takes a different mindset. There's a real problem. It would be fun to try and solve. But in terms of expanding our knowledge, knowing what are the right questions to ask, dealing with ambiguity, dealing with ethics, it's not about what's viral, what's most likely, what's probable. They're bigger questions. That's really what humans still need to do, certainly for the near term. Understand it's not the knowledge that you've learned. AI has that covered, but the ability to ask questions, to frame problems, to deal with the uncertainty, that is really what our value still is. The way we language reality masks our reality.
Hello, David Giltner. Thank you so much for being here with Chung Huong Institute podcast. Dave, I'm kind of blown away. So you're a physicist, you're an academic, you're a researcher, you train PhDs, you build partnerships. What do you not do, and how do you even do all this?
Sure. Well, thanks for having me here. So I am a physicist by training, and I started my career as, that. So I have a PhD in physics, and of course that was absolutely an academic career. I built most of my career in industry, and that's actually a big part of how I got to what I do now, because that transition into the private sector was a challenge. It's not something we're trained for. Many of us as scientists imagine that we will become professors. That, you just, if I think, how did I follow that path? Well, it starts with an interest in science when you're young, and at some point, you declare a major in college. I had to choose between, I did choose between physics and music, and I thought physics is probably more practical. And so then you think, well, if I'm going to be a scientist, I need a PhD. And you just imagine, I guess I will be a researcher and a professor at a university. But it was in the last year I decided, after watching my advisor and the other professors, I love science, but I don't think that's the career I wanted. And so I transitioned into industry and have worked at basically laser-based companies for most of my career. But what I do now is, so I have my own company, and it really started, I guess, way back at that point when I decided to go into industry. And my advisor said, well, if you want to go into industry, you're pretty much on your own. I don't know anything about it. I just understand academic research. That's all I know. She wanted to help me, but she just didn't know anything about it. And this is, I've realized in the time in between, this is something that a lot of us have dealt with. In 2010, I had an opportunity to write a book, and I had met a guy who was helping people publish interview books where you interview a bunch of people about a specific topic. And first of all, I thought, well, hey, that'd be great if you have a book, people ask you to come speak, and that would be fun. And I happened to be looking for a job at the time, and so it reminded me of this same challenge of being a scientist but working in the private sector. And I thought, I know I will interview other scientists working in industry, and that would be the reference book that I would love to have had when I was looking for my first job, making that transition. And so then I got a job and I was speaking on the side. But over time, I started to realize, yeah, this was not just me. There's plenty of people around the world. I started getting invited to speak internationally. It's like many of us scientists struggle with this. We're trained to be academic researchers. Most of us, 95% of us or so, leave that, and most of us work in industry, and we don't learn anything about it. And what's more, it really takes a different mindset, because in research, you're trying to create knowledge. In industry, you're creating solutions for a profit. And so that is really where I decided in 2017, I left my job that I had at the time and decided, I think I can build a business out of this. There's a real problem. It would be fun to try and solve. And so that's what I do. And I've written a couple of more books since then. I have them on the shelves behind me here, the orange one and the blue one. And so it's developed from where I started. I really do two major things. I help scientists understand industry for two major directions. One is for scientists that want to go get a job in industry. And the other is I help researchers, scientists who stay in industry, partner with industry for a variety of reasons. It sort of starts with new revenue, research funding avenues, but it's really about innovation, about helping make sure that the new ideas generated in academic research make it out into industry. But a lot of it's all around helping scientists understand how does industry function so they can either go get a job in a company or they can partner with a company. So that's what I do now.
That makes me curious about so many things. So, why did you choose to leave science?
So that's a good question. I guess the big reason I chose not to be a professor is the way I think of it. Although, technically I wasn't doing science research anymore. It was watching my advisor and the other professors in their careers. They loved them, but I realized after 5 years or so watching them, 5 years later, they were in the same office and working on the same research, same colleagues, same committees, same everything else. And I thought, I don't think that's really what I want. I had a lab partner named Roger who had done an internship, and he talked about this great place called industry where you build things people need and you ship them to them. And, if they like what you built and they buy more and your boss is happy and you make money. And I thought, oh, I will give that a try. Of course, I really didn't know much of anything about it, but I guess that's why I decided to do that.
So, when it comes to partnerships, then academia, industry, how does
Hmm.
that work? I mean, how do you convince them? And this is a very selfish question. As having a nonprofit, we partner with universities and we partner with academics also, and being an
Yeah.
academic myself. So, I'm curious, what's the
Yeah. Well, it starts with, so when you say how do you convince them, I suppose there's two sides. So how do
yeah.
you convince academia? Generally, the interest there starts with an interest in new sources of research funding. I mean, research funding can be hard to get. The classic game of submitting proposals to federal funding sources, it's a challenging game. You have to figure out how to write a good proposal. But industry collaboration offers a new avenue. And once we start to talk about that, I help them see some of the other benefits, and I think those things really start to sell them on it. Benefits like when you connect with industry, you get a lot more insight into research directions that will ultimately be commercially applicable because you're tied into that. You're not just chasing things that are novel and interesting, which have value. I mean, I fully support that, but it's valuable to have part of your research aiming more at things that are likely to be commercially viable. But it's also really great career preparation for your students and your postdocs. As I mentioned, 95% of us leave academic research. Most of us go into industry. We don't learn about it. When a researcher or a professor collaborates with industry, it brings that industry mindset into their lab. I talk about both a research mindset, which you need for research, and an industry mindset or a development mindset. And they actually practice both of those and learn which is needed in each situation. It makes them very versatile, very influential. So that's the academic side. We can come back to that if there's anything else you're curious about. But on the industry side, how do I convince them? It's really about innovation speed and a much more efficient approach to having a research and development group. So, companies have to be focused on getting product out the door ultimately, right? And so the people that they hire as employees need to be focused for the most part, on short-term tasks. Uh, Sometimes people in academia think, oh, companies have all this money, but they have to run a very tight ship and a budget and really spend only on the things that are most important. And so there are always questions that are not so critical, less important, but still valuable. Questions that need to be answered for the technology roadmap. Where are we going in the next year or two? How do we stay competitive? And there are often enough distractions from the near term focus that it's hard to put employees on that. It's hard to hire somebody in only for that purpose. A lot more research was done in the past, 30, 40 years ago. If we think of AT&T Bell Labs, Xerox PARC Research, Philips Lab in Europe, they did a lot more research and came up with a lot of ideas that ultimately turned into commercial benefits. but it's a hard return on investment, a hard ROI because there's just a lot of overhead. So instead of having a lab at the company, getting all the equipment and hiring full-time researchers, company really has an advantage if they contract with a researcher. It's a flexible, low overhead kind of situation. These people already have their labs and their equipment and their employees, effectively, students, postdocs, and they just work with them on a contract basis. That becomes a really great, efficient way to have an R&D team that you can guide, but you don't have the full overhead. So those are some of the key benefits there. Plus, then they often have great access to the graduates from that research. It's a great, efficient staffing because there's less risk to hire somebody you've worked with over the last couple of years in a collaboration sense. So it's kind of a lot there, but that's how you convince both sides.
I'm curious nowadays, and this is going to be pretty broad,
Hmm.
forewarning. Nowadays, we have AI taking over everything, right?
Yeah,
So, how with academia, research, industry, it's changing. Lots of
yeah,
things are changing.
right,
And we don't even know if we're talking to a human or if we're talking to a bot.
right,
And
right.
really,
Yeah,
so what do you think is going to survive? What do you think is going to thrive? What do you think is going to go to the wayside? Where do we need to pay attention?
yeah. Great question, and I certainly don't think I have the answers, but I actually gave a presentation, a webinar for UTH in Zurich on Monday where they had specifically asked about this. So I thought about it ahead of time. AI is great for sort of processing things that are well defined, whether it's automating tasks that are well understood. Um, and it can search through lots of data, propose ideas, but it really doesn't do well. And interestingly enough, when OpenAI released, I think it was GPT-5, they said PhD level expertise. I forget the exact wording, right? At your fingertips, for $20 a month or whatever. But that really comes from a misinterpretation of what the real value is. And this is what I tell scientists, like AI is a great tool for these things that are already understood. If you think about what it really does, it looks through everything that's already known, and it's pretty good at figuring out what's the most likely thing, right? All it does in predicting language is say, what's the next most likely word based on what's been said? I mean, that's essentially the way language model works and has a lot of value for accelerating things and for being an awesome tool. But in terms of expanding our knowledge, knowing what are the right questions to ask, dealing with ambiguity, dealing with ethics, where, it's not about what's viral, what's most likely, what's probable. They're bigger questions. That's really what humans still need to do, certainly for the near term. I mean, as we move towards AGI, who knows? It's a great question, but at least at the moment, that is where we can utilize it, but where we still have value, and particularly for the PhD scientists I work with, helping them understand it's not the knowledge that you've learned. AI has that covered, but the ability to ask questions, to frame problems, to deal with the uncertainty, that is really what our value still is.
So you mentioned language, and this
Mhm.
question I was going to ask you at the end because we have a ritual where the last podcast guest asks a question to the next one, but I want to cheat a little because this is related. So your question from our previous guest is, when you hear this sentence, what arises in you? The way we language our reality masks our reality.
The way we language reality masks our reality. What comes to mind? Wow, that's an interesting question. So, a language is a way of communicating, but think I'm no linguist, but it, I guess, puts a pattern or a template onto our thinking. And so, what I think of is when we put it to words, there's a limitation in that. That's certainly very practical, obviously, for communicating. But anytime we categorize something, it's a simplification, right? It makes things easier, but there's always something you lose. Uh, I guess my answer is yeah, when we apply language to something, we're putting a specific template on that. We all know, have heard the stories about different languages where there's a word for it in this language and there's not a word for something in the other language. I think that's just an example of that kind of a thing, right? Learning a new language can actually impact how you think about things because of the vocabulary and the concepts that are there. That's what I think of with that sentence.
How about with AI? Because nowadays so many people sound like AI, right? We used ChatGPT for a while and
Yeah.
suddenly we sound like it.
Boy, yeah, I mean that is so true. The thing that comes to mind is I spend a fair amount of time on LinkedIn. That's my only social media, really. And one of the big debates is uh, trying to finding posts that are supposedly AI generated. But of course, when you look at how AI works, it takes kind of the common themes from what we have said up to now. Well, that just says really it's just mimicking what we've done as humans already. And so I'm not sure it's so obvious. In fact, I've experimented with AI, what would you call them? Like websites that will tell you if something is AI or not. And they've had a horrible, I'll take something that I generated by AI and it thinks it's human. I'll take something that I wrote and it thinks it's somewhat AI. So, let's see, I might have forgotten the specific question, but that, oh, so what do we do with that now? Yeah. So, is this a way that somehow we will come to a more I sense that, let me see if I can put this into words. So the world has gotten smaller with the internet already. That's something we absolutely saw. I mean, that's been very interesting to watch. I travel a lot internationally, and just English skills, language skills of people that I work with has gotten so much better. And they say, well, I watch things on the internet and I learned English there. And that's why they'll have very little accent often, far different than 20 years ago. And now we have access to AI can convert anything, translate anything into any language. I think this is just another step in bringing us all together, which has a lot of benefits. We've been struggling with differences around the globe for as long as recorded history, long before that. So I think that's really good. But it will probably also, I'm sure it already is, bringing us a bit more to a common mind, common ideas, and that's probably good for us getting along and interacting and communicating. Perhaps that limits us a bit in terms of new ideas and things. I don't know, but that's what I think is probably happening. And AI just accelerates that, right?
It makes me think of like these three bodies of we have ways that we know things, right? The ways of knowing.
Mm.
We have knowledge itself.
Mhm.
We have wisdom.
Yeah, well, let's see. Ways of knowing, those are methods. Knowledge is more what's created by that. And then wisdom, yeah, that's an interesting distinction between knowledge and wisdom. Uh, Knowledge, I guess, is just facts, and arguably AI is great at collecting knowledge, right? It can collect things from around the globe, every corner of the internet, and bring it together. But wisdom is more of a, I haven't really thought about how to define this, but there's a judgment that comes along. It's one thing to know things, it's another to have a feel from experience. That's the only way wisdom uh, comes to you, from how things actually play out, and understanding, whether it's human beings, whether it's potential issues, conflicts, discoveries. It's kind of a, it's not, it's an informed view of knowledge, I suppose, that, comes. So of those three, the methods come first. They create the knowledge, but then after experience combined with knowledge is what brings you to wisdom, I suppose. So I see them on a timeline.
I wonder, like in the old days, before any of us were born,
Uh-huh.
right? And the ancient wisdom traditions, they didn't have these book knowledges like we have now.
Hmm. So like before writing even.
Yeah, before
Yeah.
writing, before reading,
Yeah,
or
we had to discuss. Yeah, we had to discover on our own, and I guess the way things were recorded was usually through stories, right? I've always been a bit curious about that. I'm a fan of stories. In fact, in my workshops for scientists who want to deal with industry, I have a section I call Telling Better Stories with the Same Facts, because we want to be factual, and scientists are good at that. But in an academic research setting, we can usually talk to another scientist and just kind of list in boring rote fashion what we're working on, and they probably understand. But when you're moving outside of the research lab, you can list all the facts you want, and oftentimes people who are not scientists don't understand why any of it matters, right? And can get lost pretty quickly. It's not a matter of how smart they are, it's a matter of do they understand the context? And so stories are a great way of taking facts, but helping people understand why they matter. And so I teach storytelling. I teach how it's valuable in a career for helping someone who's not an expert on what you do understand why it matters. So it's interesting thinking about for so long in human history, stories were the way things were recorded and transferred. And I've always wondered how much those stories might have evolved as they were told around the globe. It's a big place. I'm sure you've heard of the telephone game.
Yeah.
I don't remember where I first heard of this. You set people in a circle and you whisper to one person a phrase, a sentence, and then they're supposed to whisper it to the person next to them and whisper because that produces just enough uncertainty. What you see is it travels around, and you can only say it once. I think that's the other thing, right? As it goes around the circle, when you get to the other side, usually the sentence is completely changed because somewhere along the line, usually many steps, something was missed. It was misunderstood, misinterpreted, whatever, and it carried on that way. I've always wondered, obviously we have our own issues with truth now, but at least it is possible to record it and have that exist and have that persist. But I wonder how much stories evolved.
In 10 years from now, I will have a totally different experience than you have. And we tell a totally different story. And this whole podcast was completely different, except for the data that we see online.
Yeah. Yeah. I mean, it's funny. Here's how I think of that. So I graduated got my PhD, it's pushing 30 years ago now, actually. But I'm really close friends with a few of the other fellow students. There's, four of us guys that have stayed in touch and still see each other periodically. So we talk about things that were that long ago. And that gives you an interesting snapshot in how obviously details get lost. We only commit so much to our long-term memories, conversations, other things. We may capture the essence of the conversation, but somehow we heard it a little differently. We all have our own filters. That's a really interesting experiment.
How does physics see consciousness?
Ooh, boy. I'm not aware that physics has any opinion on that per se. I mean, it's a great question. I've seen more discussions of consciousness lately than I suppose ever before. And since, I don't really study physics anymore directly, I certainly did at one time, and I've certainly used a lot of physics, but I've never really had a solid conversation with any physicist about where does this, apply. But I'll give you my own perspective, having studied it. Certainly physics is kind of the base level science, right? You've got chemistry and biology that are just more complex levels of that. Well, physics, we study the very fundamental things, as fundamental as we can get. And of course, we're still pushing in that direction. One time we found atoms, and then we realized, oh, wait, there's protons and neutrons and electrons. And oh, wait, goes further, there's quarks. And now we're working beyond that. But at this fundamental level, the interesting thing about physics is it's causal. It's not deterministic anymore because you have quantum mechanics, of course, but there is still cause and effect. And that is an interesting question. If you say, well, it's all cause and effect, what does that really mean for consciousness? And I don't have an answer to that, but it does seem to suggest some kind of a causal framework. Most humans kind of imagine, we have our consciousness is just our what we are from moment to moment. Many of us imagine we have a free will that is capricious and not causal at all. Physics would seem to disagree with that if you ask me, but so I don't know that there's any real picture on that from physics, except that, what I mentioned. Well, it seems as though there's a causal framework underlying all of this.
You mentioned physics doesn't see free will.
Yeah.
So, can you say more to that?
hmm I mean, that would be my opinion. Now, maybe a physicist would disagree, but generally in discussions of free will, so I guess there are two ways that I think of people, when they say free will. I think one is that if I were to, like, say, I make a decision, if I were to back up and somehow replay that, I would have the ability to make a different decision. That's one way, right? Whereas if there's a causal framework, well, that wouldn't really happen. That wouldn't really be possible. Somebody could say, well, quantum mechanics, there's randomness in that, so maybe it would be a different outcome. Right, but that's different than saying I somehow chose something different. The other element of free will usually is people have this feeling like they are there's this self that is the creator of their thoughts. Like, I think my thoughts. And this, I don't know what physics would say about that so much, but being a scientist and observing the way things happen, I think, I don't know, my experience when I'm calm and just sit and watch my thoughts, they just spring out of nowhere. I don't create them. I mean, saying that I created them would suggest I could tell you what I'm going to think next. I don't, I can't do that. That makes no more sense. I know no more what I'm going to think next than what you're going to say next. And so, that's not physics per se, but that's how I, as a scientist, approach that problem. It's like we have this idea that there's this free will. We feel that it's important, but when you look, it doesn't seem like it's really there. And I think that's an important element of what consciousness is. So,
Is there still a big debate between quantum physics and physics? Like the physics? I don't know how to differentiate that, but I think you know what I mean. Um,
so, I wouldn't say there's a debate. There is, I mean, if you go deep enough into it, and I'm not an expert on this, I said we're pushing past quarks and subatomic particles and things. We're still trying to figure things out, but I'm not aware of a debate per se because we teach quantum mechanics and we teach classical mechanics, and those exist side by side. What is certainly there is quantum mechanics is hard to understand from a like an intuitive sense. And so, but we can use it there. We know the equations, we can do calculations, our computers work, they use quantum mechanics, all kinds of things utilize it. We know how it works. So there isn't a disagreement about that. It's more trying to wrap our heads around it, I think, and how do you interpret it? And well, this kind of gets back to something you said before. I think of that as if you talk about different interpretations, we're trying to put language on it. We're trying to apply language to something, and well, there's really no guarantee that our language can fully describe something in the physical world. I mean, it's just a tool we came up with. There's no reason to believe that we can intuit how the universe actually works. We seem to be able to do that for a long time, but quantum mechanics really represented a break where things just they behave so differently in that realm is probably a good way to say it, that our intuition doesn't fit. I mean, one example most people are probably aware of is matter and light can both behave as a particle and they can behave as a wave, and it all depends on how you're interacting with it.
huh.
And there are others. There's the Schrodinger's cat model is a way of trying to bring the strangeness that is quantum mechanics out into the real world so we can see how it appears. So I wouldn't call it a debate as much as it is hard to wrap our heads around it. And I think there's an ongoing discussion about how to do that, or how to explain it to people. You know, here I live in Colorado. I guess we both do in the U.S. And I'm near Boulder, where there's a lot going on in terms of quantum technology now, because a lot of the basic science was generated here in the area. And so there's a lot of talk about, well, if you want quantum technology to move forward, there are lots of people who are not quantum scientists that you need to help understand why we want to move this forward. What is the benefit of quantum cryptography and quantum computing and quantum sensing? Why do we need these? And how does it work? And when it's hard to explain intuitively, that becomes really challenging. So I've heard a lot of conversations around how do we do that?
Do you think that you would be able to wrap our heads around this within just a few minutes for those who are listening so that maybe they can understand why this is important, why they should be aware of this quantum
Sure.
technology or quantum physics and how it is applicable in daily life, why it's important to know rather than kind of, wandering through life and
Yeah. Well, the short answer would be the kinds of things we can build with using the technology. Now, we already use quantum mechanics in plenty of things. The computers that we're talking on now use quantum mechanics. Uh, LEDs use lots of things use quantum mechanics, but some of the quantum technologies that are being developed now that we're talking about them use some of the principles at a more fundamental level. Um, Quantum computers, for example, now you're talking about having a qubit. So instead of a classic bit in computers, a switch that can be on or off, now we're talking about a quantum bit, a qubit, that can have an infinite range of options. It could be up, it could be down, it could be a linear combination, little hard to explain without going into quantum mechanics, but that allows you to do very different kinds of calculations. Certain things can be done far faster, and that's what gets to quantum cryptography, where we have encryption methods, and they are strong because it takes a long time to break the code, while quantum computers will be faster at breaking that, and so we have to find a way to stay ahead of that so our data is still secure. Those are some of the ways, some of the things that are, so you can see why it might be important.
especially again coming back to AI in today's
Mhm.
age.
Mhm.
I mean, physics is way beyond my scope. I think it's important. I think it's fascinating and probably safer if we all know and understand anything.
Yeah.
But when I have a question, I have put it into AI
Mhm.
and I tested it with one of my friends who he does he works with quantum physics. And I said, "Oh, is this, the answer? And do I understand this correctly?" And he's like, "This is amazing. You understand everything, but it's all AI." Later I say it.
Mhm.
But I wanted to test the waters and yeah, so I'm curious what catch up looks like then.
I mean, it gives you, it's amazing the access it gives you to so much information. I've been experimenting with it as well, and Google has been great. You can search anything. This takes it a level beyond that, and
Yeah.
it's really quite impressive. Yeah, now, of course, the other thing is, well, it can hallucinate it. It's not always right. It can misunderstand what it's pulling. And so, that creates an interesting situation where it can answer any question, but then you have to figure out if it's right or not, which kind of begs the question, well, then how much can you lean on it in the first place? If you have to prove it, how can you rely on it? So, I have found that the most value I've found with it, I've certainly been experimenting with it in many different ways, is idea generation. Not so much telling me what something that I need to believe, but giving me ideas. And I can always say, "Oh, I like that," and no, that's not even right, and no, that's not quite right. But it provides me with ideas that I may not have come up with on my own. But I still provide that judgment, back to the earlier conversation we were having about what it's good at and what it's not. I saw a really interesting post on LinkedIn a couple of weeks ago talking about how, um, because of this, perhaps AI is simply accelerating the Dunning-Kruger effect. Are you familiar with that? Where, people who know, if you imagine a curve, people who are experts in something are very confident in what they know. And as you come down the axis in knowledge, well, usually people's confidence drops too because they're aware of what they know and they're aware of what they don't know. But at some point, humans, they don't know enough to know what they don't know, and the confidence level goes up. And I started to think about, how, wow, absolutely, somebody could put a question into AI and it could give them the wrong answer. And if they have no clue whether it's right or not, they go off thinking, hey, I'm an expert. And in fact, they might be completely wrong.
I
Um,
I recently had someone said to me that they did a meditation teacher training with ChatGPT, and that is why they're certified to be a meditation instructor, and we should bring them on. And that was a little surprising to me, and it probably shouldn't be. But yeah, I see that quite a bit.
so that's interesting because that makes me think now about the earlier discussion about the difference between knowledge and wisdom. And, in any kind of teaching, meditation, I suppose, or anything else, it's not just enough to know the facts. You have to understand how people might use the ideas, how best to communicate them to them, help them understand it. There's a lot more than that. One of the things that I talk about in my workshops with scientists when we talk about your strengths, so if you're going to engage with people for a job or industry partnership, whatever, you want to think, well, what are my strengths? Either the strengths I bring as a person or the strengths I bring in my lab. And one of those strengths is knowledge, the things you know. And I always say, well, there's factual knowledge that can be taught or is in a book, but then there's experiential knowledge, which is just things you have to learn. And examples are like, you know, uh, if you teach which questions students get wrong. I mean, okay, once you understand that, I suppose that could be in a book, but that's something you learn through experience. Or I work with medical students sometimes, how to give a patient bad news. Well, there's not even a single answer to that because if you're going to give somebody bad news, part of it is how you interact. What works for you may be different than what works for somebody else. So this idea of experiential knowledge where you can't just go learn it somewhere. You have to work through that and figure out what works best for you or for the situation. That's really closer to wisdom. And that's something I think that AI can't currently process. So again, it gets back to that question of, where it is knowledge versus wisdom.
Talked about how AI is now developing consciousness. Then I explore further. How are they defining consciousness? And I think this is really important when we're talking about anyone is talking about consciousness in general. So when
Mhm.
people are talking about AI developing consciousness, it seems they're talking about process. Anything that can process information has consciousness, according to this theory. Now, I don't necessarily agree with that because then we would be saying our phones and our computers have consciousness and our lights.
Yeah. I mean, I'm trying not to just say, I don't know, being a physicist. And I guess I suspect that at some level, it really all just comes down to the matter that we see, uh, you know, protons, neutrons, electrons. And of course, as you break down from there, consciousness, I strongly suspect that we will end up figuring out that consciousness is more like our personal experience, but not necessarily a thing. It's just, if you put that many neurons together in one spot and can do all that we do, there's an experience of that. Maybe not so different than our experience of free will, right? It feels like we make decisions and we control where we're headed, even though it's almost certainly all causal. I think that consciousness is probably something like that. I don't know that there's a thing or a substance or anything that is consciousness. It's just that's the experience. After all, it's really always personal. There's nothing we can nail down and say, here is consciousness the way we can. Here's a neuron firing, here's a biochemical reaction. That's what I suspect, but I don't know.
That's interesting. It kind of brings my mind back to knowledge
Hmm.
and and also back to your working with PhD students and back to the work you're doing in general, Dave. A lot of times PhD students are like, let's just get this research out of the way, publish it, do a dissertation, publish along the way, get the paper that
Yeah.
says I'm a doctor,
Yeah.
get out, right? I really, I seldom see real world application and results. I don't know if that's your experience, but very rare.
I mean, it's certainly many that you can talk to many PhDs who will say, my PhD research was not groundbreaking. It was not, it didn't do, anything on its own. That doesn't mean that it isn't one element of something that will. Usually before a new idea can be commercialized, can be turned into something, there's usually a lot that is involved and not any one PhD project. Um, it's that's the scale of what needs to be developed. But I have seen many things that are developed and turned into something. One way to look at it is I've met a lot of entrepreneurs who developed something, found something during their PhD research and thought, hey, this could be a company. And so that's a good example of that. Although rarely was the the commercializable idea based solely on their work. It was probably other people in the lab, and it takes a lot to get to that point. So, I think in general, in basic research, well, frankly, this is the feeling of so many of us when we graduate. We do some work that hopefully will someday turn into something, but a lot of times the timeline can be very long too. That's the idea of curiosity research, which is ultimately what science is. You find something new, but that doesn't mean that it's applicable. You could even say the discovery of the laser, the development of the laser, which wasn't any one PhD project, was, oh, I think it's nearly 60 years ago that was demonstrated now. And for a long time, nobody knew what to do with it. And yet, eventually, as we figure it out, now we have lasers in so many different things. It's unbelievable. And you look at it at the time, there were people saying, yeah, great, but what are you going to do with this? So, it's a pretty complex dynamic. It's one of the reasons that I like academia industry partnerships because that does provide a path for directing research in more commercially applicable ways. It is entirely possible for a research group to chase novel new ideas that maybe don't have much promise. I mean, sometimes it can be just because there's no economic path to developing a solution. I spoke to a biologist years ago. I think he was in synthetic biology, talking about how there's a lot of research done on antibiotics, for example, that will never turn into products because it's so specific on a particular bacteria, a specific disease. And while it's great, it costs too much to bring something to market to ever invest in that one antibiotic. Nobody could make money doing it to just cure, a disease that affects a handful of people. And I thought, wow, that is really interesting. So you can even have research that in principle is valuable, but it's just such a path to get it to actually turn it into a solution that even good ideas don't turn into commercial solutions. So, again, back to the academia industry partnership idea, part of that is to try and help provide a path that at least hopefully provides more of that connection. I mean, it does in practice. We see that, right? So, because industry can say, well, here are the problems we're seeing out in the real world, and here's the business model we have, and can you do some research that looks at this problem because we think it's more likely to be something that we could work with, and it helps enhance that flow of ideas. But there's certainly a lot of research that doesn't ultimately turn into anything, or at least not yet. Who knows?
That's interesting because I think of the 1%, like the diseases, the ailments that happen in 1% of the population or less.
Hmm.
And how many answers are actually already out there, but all because of money, because of whatever,
Yeah.
um, it's people are dying.
Yeah, I mean, it's a really interesting question. And of course, it's not enough to turn it into something that could be sold. We have regulations, in the US, the FDA, that tries to make sure that we stay safe and says, well, you really have to demonstrate a fair amount with a new drug of any kind to make sure it's safe. And that's absolutely true because you could say, hey, this antibiotic seems to it's great at killing this particular bacteria. That doesn't mean that it would be safe for humans. I mean, we don't know, right? And if you even test it on a couple of people, well, great, but that's very different than testing it on millions of people. It's often said you could put together a plan to go administer saline injections to people, and there will be problems with that, right? Just because it's turning something, this is true for any product and certainly for medications, turning an idea into a scalable solution of some kind just has so much involved with it. It's not simple to do. So yeah, to your point, I mean, you can have what might be potential solutions out there, but the investment required to actually turn it into a verified and validated solution is can be prohibitive.
I recently interviewed Dr. Robert Harris from Karolinska University. Mad
Mhm.
Bob on LinkedIn,
Yeah, yeah. I'm familiar with him. We're connected and I see his stuff. Yeah.
yeah, he just joined our team, and so we feel really lucky with that. And I learned from him that he created this. He had this idea basically where, and we're going to publish it soon, but for the ones listening, it's already published. And he had this idea that if you inject these parasites, it'll remove a certain kind of disease. Um, and everyone thought he was crazy, right? They like disapproved. It took 10 years or more to get that to be approved and to be a thing, and now it's a cure for one of the diseases that we have.
Oh,
Because his
wow.
theory was that inject the parasites, it's easy to remove them later, but the disease will be cured.
Yeah, that does sound really interesting.
Yeah. I'm curious, Dave, how are you preventing burnout from yourself, with yourself, and how are you teaching others to prevent burnout? I mean, especially in academia, and I imagine mixing academia and industry is a bit tiring, even with a passion.
Yeah. Ooh, I think the thing that I have learned in my career to prevent burnout is paying attention to what matters to me. It's easy probably in any career, and certainly in my career in industry, to at some point be chasing something somebody else wants more than you do. And you combine that with if you work for them, well, then you have to do it to some degree their way. As a PhD scientist, I've always had some leeway. Part of the idea is you decide how to solve problems, but you can always end up chasing something that matters more to someone else. And that can be a real problem, especially if somehow you begin to disagree on something, at a more fundamental level, values, how you're going about that, ethics, something like that. So, I mean, now I have found that creating my own company, solving my own problem in a way that I think makes sense, has been great. I mean, and of course, there are stresses, of course, there are challenges, but not really burnout kinds of challenges. I'm working at the pace that fits me. Yes, I have disappointments and things that don't go well and work that I'd really rather not do, but it's just not the same kind of a thing. So now, not everybody's going to do that, but I do think that staying in touch with what matters to you is really important. Well, here's an angle on it that I talk about in my workshop. So after I go through 5 steps to help them figure out, how can you build a career, especially if you're just coming out of academia. And at the end, under the fifth thing I call it is think big, because there's a lot more options out there than you're probably aware of there in grad school. I know it was for me. The people will tell you what a PhD scientist can do and what they can't, and a lot of times that comes from their own ignorance or concerns or worries. But one of the things I say in that is whatever career you pursue, you will earn a financial salary. And obviously that's important because we have to pay the rent, pay the mortgage, buy food for our families, all that. But you will also get a psychological salary. And I encourage them to take that seriously. It can be easy to chase a financial salary, but your psychological salary, what is it about what you do that matters to you, that feels rewarding, that feels like a good challenge? There can be stress involved that is part of what you like. But I think being in touch with what matters to you and how do you want to balance the financial and the psychological salary, I think is an important part of making sure you don't burn out or just end up in a place that doesn't fit you, whether you call that burnout or not. It's all around. I'm big on how can you design a rewarding career, and I think if you keep that out in front of you, that's pretty important. It can be so easy to follow a path that is for other people, not for you. Advice is great. Watching other people, taking examples, all great. But you have to stay in touch with what matters to you. And it's just so important for many things in your career.
Is this part of your formula? One of your books? It's not a game, it's a formula.
Yeah.
Can you tell us a little bit, maybe? I'm really tempted to say, Dave, can I know the formula immediately? But I know that may not be very ethical, so I'm curious what you can share.
Well, the whole idea is it's not a formula, right? So that's this book here. It never shows up on camera, but it's a
It shows
game,
up.
not a formula. Can you see it?
Yes.
Good. Okay.
Oh,
Yeah.
I said it wrong.
That is the title. It's a game, not a formula. And
Uh,
in a nutshell, so what it's talking about is how the subtitle is how to succeed as a scientist working in the private sector. And the big contrast that I talk about, the principle is what we learn in academic research is to find the right answer, right? That's the whole idea. We're trying to discover something new knowledge, as we've talked about. But the whole idea is you want to test it, verify it. The scientific method is amazing at doing this. It's the best tool we have for coming to a consensus around something new, right? It may take years or decades, but it's great. But the whole idea is we come up with something that is the right answer. And as a physicist, usually that is truly a formula, right? We try to figure out how to write an equation for something, whether it's, Hamiltonian in classical mechanics or whether it's Schrodinger's equation in quantum mechanics. We talked about that. So the formula approach is what we learn in academia. It's finding the right answer. And it's something we all learn, whether we're scientists or not, when we're children. You go to school and you take a test and you learn very quickly that, oh, if I have all the answers and I get the answers right, my teacher's happy and my parents are happy. And you learn that if I pass all the tests and I pass the class, and again, my teacher's happy and my parents are happy. And you learn very quickly this is about having the right answers. And that goes all the way up into if you go to university, they give you a list of classes and say, if you pass all these classes, then we'll give you a degree in this particular discipline. And it just really reinforces that there's a right way to do things, right? I get all the answers, know the right answer is a right way. And of course, as scientists, like I said, well, our job is to find the right answer. So this is a really strong uh, mentality. It's the mindset, and it's very important. We can find the right answer. It's so cool that we can do this as human beings that's what's great about the scientific method. But when you move out of the research lab, and it's true in your personal life, but it's certainly true in an industry career, now, even at a company that is based around science, there are so many other things that are uncertain, that are not predictable. The fact that you're working with human beings and you're trying to survive in a variable market and you have customers who you don't control and suppliers and business partners you don't control, and there's all this uncertainty, it's no longer about the right answer. And the transition point often comes when you're looking for that first job. We have a tendency to still take that checklist approach. I mean, I get this question from PhD candidates about to graduate. Well, if I want to get a job in this particular area, what should I do? Are there other certifications, classes? You can see they're looking for a checklist. And I say, at some point, this is more like a game. There's no right way to do this. That's one way. It's like a game. There's no right answer. If you think of a game, sports or not, there are many ways to win a game. That's how you get competition, right? Uh, Second is winning requires taking risks. You have to try things and you don't know if it's going to work out or not. We're not really comfortable with that as researchers often. Sure, we try things that may not work in the privacy of our lab, But we can work on that for months or years. And when we finally come up with the answer, then we can say, ah, I've got Eureka. I found it,
Yeah.
But on a regular basis in an industry career, you have to make decisions and make recommendations, try things, and you don't know if they're going to work. And then the third way, this comes back to knowledge. I say, well, knowledge isn't really power. You hear the phrase knowledge is power. I'd say, well, not really. It's only power if you do something with it. It's absolutely can be a key to power, but you have to do something. You have to apply it in some way, and that involves taking the risk, and there's no right way. So, they all fit together. So that's why I say it's a game, and that's how it contrasts with what I call formula thinking because we're scientists. You could say checklist thinking or recipe thinking where there's a right way to do it, but that's the way it works. And I find that that works not just in my career, but that's actually a good way to think of life in general. There's no right answers, and you have to take risks and knowledge. It's great, but it's not really power. You have to do something with it. So yeah,
Oh,
that's
I think I've been playing the formula, seeking a cheat code and not knowing that I was in a game.
it is so tempting, right? We all do that. It's not just scientists. We all want to do it. I think though that, people that you know, head out into the work world after a high school degree or after undergrad degree, I think get used to that sooner. Whereas those of us that spent an extra 7 to 10 years in a research lab, I think it just really, you're learning to work in that environment. And I think it's like I can find the right answer. I think it's reinforced in us. And so we struggle more. I think we have more of a tendency to look for that formula, the right way to do things. It's very tempting.
Thank you, Dave. Dave, last question for you. If you could give any advice to the next generation of scholars, what would you say? Don't say it's not, don't say it's a game and not a formula. Keep
Yeah, that's so if I could give advice really to anyone, next generation, and I give this advice to the scientists I work with, have the courage to create your own path. It can be tempting to look for a map to follow someone else's example in whether it's your career or your life and and follow that. And that's fine, and that's a way to do it. But I certainly have learned that being willing to step out and kind of, forge your own path, bushwhack, head through the jungle, whatever, has so much value. It can feel a little scary, but that is where the really interesting stuff is. My wife and I, we like to travel a lot and adventure things. And what we found is if you're with a group of people, there's a point where they all stop. Most people don't go beyond this level. And we tell ourselves, if you go beyond where most people stop, that's where the really cool stuff is, whatever it might be. And that's part of it. You don't have to, but I certainly encourage people to have the courage to venture out into the unknown because there's really interesting stuff out there that you may never have imagined was there. And you can, whether it's your life, your career, you can end up with a life and or career that you never imagined and is more amazing and rewarding than you ever expected.
So you got to pass level two, take a risk.
Yes, yes, exactly. And that's part of it, right? I think people who take risks, they're happier. I mean, it's because instead of, sitting back and feeling the fear and thinking, oh, I should do this. You hear so many people say, well, I wanted to do this, but I never did. Oh, I feel so bad for people when they say that. Most risks are not nearly as bad as you imagine, right? And, even if you just sit on the sofa and go nowhere, well, now you risk dying from poor health. So, it really is worth taking some intelligent risks, calculated risks. I mean, become an adrenaline junkie and go, you know, base jumping or whatever. Although I say this as an ex skydiver, I was a skydiver for a while. I never did base jumping. I always had a reserve chute, but there's just really a lot of exciting stuff out there. And the more you probe it, the more you realize, wow, life can be pretty exciting and amazing. And
Thank you, Dave. Thank you for taking a risk to be here with us today.
You are welcome. This has been great. It's been really fun talking to you, Sachandra.